Stanford CS193p, spring of 2025. So today I'm going to do a little more demo, kind of a follow-up on what we did last week, some minor little tweaks that I just wanted to show you. Then I'm going to jump back into the slides and talk about, I want to say, a complicated topic. It's not really that complicated, but it's important to understand, which is multi-threading. And we're going to talk really all about the concepts behind it. It's going to be a little less practical knowledge than you're used to seeing me give you, but I want you to understand the concepts behind it so that when you go out to do your final projects and you run into some kind of multi-threading thing, it's like you understand what the parts are and what people are talking about when you read a vignette that shows you how to download something from the internet or something like that. And then we'll go back to the demo, and I don't really have a kind of comprehensive multi-threading demo, but we actually do use multi-threading in the code we have, which is that words, right? The words.swift downloads the common words from the CS193p website. It does that in the background, so it's doing multi-threading. We're going to look at that and pick it apart a little bit, try and understand it from that point of view. Let's hop over to the demo here. Remember that when we picked different sorting options, it was animated, it moved up and down, but it didn't do that with searching. So if I type ER, there's no animation. It's not sliding these things in and out or fading them out or whatever. So I wanted to do animation for searching as well. And just like it was easy to do that for the sorting, which we did, if you remember here, our sort option, we pass a binding to it into the game list. We just added an animation to the binding. So that means anything that changed as a result of the value of that binding changes got animated. So that worked for sorting. For searching, what's happening is this searchable, the thing that puts this little text field up for us. Every time it changes the search, we want to animate. And we know how to do that. We'll just do an implicit animation here. So I'm going to say animation. I could do default, maybe ease out, whatever I wanted to do here. But the value, which is what's important, is the search field. Every time the search field changes, even if I type one character, it's going to animate the results of the game list there. So let's try it. Go over here and type ER, mind, earth. So implicit animation can be powerful when you have something like searching, where it's just obvious what you're changing needs to be causing something to be animated. The second thing I said I wanted to do is add another sorting option here. We have by name and show me the most recent ones first. I'm going to add one for show me only completed games, games that I've successfully guessed the final code there. I'm going to do that as another sort option. In terms of the sort order of the completed ones, I'm going to use the same sort order as recent, because if I'm looking at my completed games, presumably I'm most interested in the ones I just completed recently, so I want those at the top like recent is. But it is just another sort thing, so I'm going to go over to my game list here. Here's my sort option, enum. I'm going to add another case, case completed. There. And of course, as soon as I add another case, I'm getting some errors here. Switch must be exhaustive, switch must be exhaustive, which is kind of a nice feature of enums, is you add another case and it just reminds you all the places you need to go and deal with that. Here, it's just asking us for the title of it, so I'm going to say case.completed, and sure, completed is what the AI suggested, that's fine by me. And then up here, it's the actual sort by, where we're choosing the query. And I said that I wanted it to be the same as recent, so I'm just going to say completed, like this. And that's it. It's actually compiling, no problems. And over here in our preview soon, we should be seeing another option. There it is, sort by name, recent, completed. Right now, we haven't done anything to search for completed ones, so it's doing exactly the same thing as recent, which is just sorting by most recent instead of alphabetically. Now, how are we going to make this completed work? I'm just going to enhance my predicate a little. Remember, I have this predicate right here, which is narrowing the list based on the search field. I'm going to add another little thing here, which either checks to make sure I'm not searching by completed games, or it checks to make sure the game is over, because I only want to show completed games. Now, I like to do these little lets before my predicate to make it so I have as few terms inside the predicate as possible. So I'm going to create a little let here called completed only, which is just telling whether I want completed only or not. So that's my sort by equals dot completed. But I'm going to use that let inside my predicate. I'm only going to show either not completed only, in which case I'll show them all, or the game is over. And all this other stuff down here. Oops. We'll let this thing build and try and get our preview working here. And it crashes. Anyone from your assignment 5 have any idea why this code that I put in here, which makes perfect sense, why is this crashing? Anyone have an idea? Yeah, exactly. He's saying is over is a computed property. And we have to remember that this hashtag predicate thing is going to be converted into an SQL query and happen on the database side. So if it's happening in the database can't see any of our Swift code. All it knows is what's in the database. It's a database query. So if we want to have game is over in here, is over has to be in the database. Has to be a field in our @sign model. Otherwise, we can't query on it like this. I'm actually thinking of 2 different ways to solve this problem. But the first one is straightforward. Let's just make is over no longer be a computed property. Here's our model. Here's is over. It's doing the right thing. It's checking to see if the latest attempt we did, we put our attempts latest one at the beginning, is equal to our master code, then it's over. So I'm going to just get rid of all of this computed business, and now this is a stored property in our @sign model, and now we'd be able to search on it. Now, we have to set is over to the right value all the time, though, which is kind of a bummer. One thing that's great about computer properties is that is over thing was always right at all times, because it was always looking at the attempts to see if the game is over. So now we're going to have to set it to true and false depending on what's going on. For example, when the game starts, this needs to be equals false. The game's not over when we started. And then also when we attempt to guess, here's where we have is over down here. Now we have to do that same little, are the pegs the same? And then set is over equals to true. This is where we set it. This is where the game actually ends as a result of some attempted guess. And when I restart, I want to make sure I say is over equals false again. Reset it back to not over. So this is kind of annoying, actually, that we have to go through and do that, and I don't like that, and we're going to talk about that in a moment here. Then this thing, var is over, I always like to put all my vars, especially in an @sign model, I like to put them up near the top here, just so I can kind of see what my database looks like, essentially what my schema is. These vars are my schema. We've done it here now, made it is over is now a var in the database. It's a bool, so it's a primitive type, so everything should be absolutely fine here. Let's go ahead and run this, for example. Let's play a game, maybe this guy. I don't have my cheats anymore. Oh, that's going to make it easy, though. Let's try that. No, so this is probably something like, oops, nope, this is purple, like that. No, this, and this. No, great, it's this. There we go. So we've got a game. It's over. Let's go back over here and see if we hit completed. Sure enough, it's only showing the completed games. So that worked. So that's great. Small modification we had to make. We had to make is over be stored. That was kind of annoying because we had to go change it, set all the places where is over might change. But I had another idea for a solution to this problem. What if I go back to my games list here, and instead of saying game is over, what if I calculate whether the game is over? I mean, I have the whole game in the database. Why can't I just look in the database and see if the game is over by looking to see if its most recent attempt, or any of its attempts actually, equals the master code pegs? So how would I do that in this predicate? How would I express that? Well, how about if I said game.attempts contains where the attempts pegs equal the game's master codes pegs. Okay, can I do something like that? I mean, that's a lot of stuff going on there. I'm actually looking in multiple tables in the database. I'm looking in the codes table When I say $0.pegs, that's the attempts. $0 is an attempt. So I'm looking in the codes table, and I'm also looking in the games table. I'm looking all over the place here and comparing these things. Is this legal? And the answer is, this is completely legal. There's absolutely no reason you can't do this. You are allowed to follow using dots like this, game.mathscode.pegs. You can do that. You're also allowed to refer to other things that are in arrays, that are in other tables. Amazingly, this thing will build a SQL query over there that does all the joins and everything to figure this out. So let's see if this one works instead of doing the is over trick. So here we go. Run over here, and it crashes. So this did not work. Anyone have an idea why this did not work? What does this say? Fatal error, couldn't find attempts on Codebreaker. Well, two things for you to learn here. One is always look in your console when something crashes, because this console, the very first line, tells me exactly what the problem is. It says there's no such thing as codebreaker.attempts. But that's impossible. I mean, I absolutely know that Codebreaker has attempts. Look, here's my Codebreaker. I've got this var right here. It's called, it's called underbar attempts. You see, attempts is this little computed var. The database can't see that. The database sees this. And this will happen to you occasionally. You'll do this little computed bar trick, and then you'll do the underbar thing to have the backing store, do that, and then you'll forget. And then in your predicate, you're using the computed one. Happens all the time. This is an easy fix for us. We just need to use the actual name of the var in the database, which is underbar attempts. It's not called attempts. So let's go back to our game list here and just change this to be underbar attempts. To run again. Whew. Let's see, it's still completed? Yes, it still sorts by that. So it's able to look in the database, do all that lookup, do this where contains thing right here by looking in both tables in the database and looking through all those things, matching up the pegs. Pretty powerful predicate expression right here. So my question to you is, and we're going to take a little poll in here, which do you like better? This blue solution or the make is over into a non-computed var? Which of those two do you like better? So all in favor of this blue solution, raise your hand if you like this blue solution. Nobody? One person? Okay, and what about the other one? You all like the is over solution. Okay, so somebody tell me, why do you like the is over better?
I prefer to define what it is over in my model.
Okay, I'm in total agreement with that. What he's saying, and I absolutely agree, is I like the idea that is over is something that's calculated in my model versus in the middle of a UI, in the middle of a predicate in the middle of a UI. And I absolutely agree with that. So even though I like having computed properties so that I don't have to worry about setting it to false and true in all the right places and I might mess up, I still like the idea that my model owns the logic of my game, you see? So I like making is over not be a computed thing more than this. But I wanted to show you this just to show you very complicated queries that cross tables are totally allowed inside this predicate. So I would definitely go back to game.isOver as well. So I'm in agreement with the vast majority of you here. The next thing I want to fix in this app is a little subtle problem. Let's go over here and look at a game. So I'm going to go into Earth Tones right here and look at the time is ticking. The time properly started there. When it appeared, it started. We know we have this whole mechanism, right, where when views appear, we start it. When they disappear, like it's at 10 or so, 10 or 11, it goes away. It's not counting up. It's not saying 16, 17, 18. So if I go back in here, see, it's still at 12, 13, 14. So that's great. That's working fine. And we even have a nice feature where when we switch over to another app, it pauses it. The scene phase thing. Remember the whole scene phase thing we do? So when we come back, it's showing us approximately the same time. But there is a problem here with our SwiftData mechanism here, which is that if you look at our Codebreaker schema, this is its schema essentially, we do not store the start time in the database. And we did that intentionally because it makes no sense. You store a start time and you come back to this game days later, you don't want the start time saying you've been playing the game for 3 days. So it makes no sense. Elapsed time is really the thing we're storing in the database that says how long you've played the game. But here's the problem. When we write to the database, when we autosave it, we don't update the elapsed time. So that elapsed time, if we haven't switched scene phase recently, or we haven't disappear and on appear and disappear, if we haven't done those things, then elapsed time has not been updated. And so what's in the database is really old. So how would we make it so that every time the database gets saved, we update elapsed time to the latest possible situation? And this is minor because a lot of autosaves happen, for example, when we switch apps. That causes an autosave, but it also causes a scene phase. So our elapsed time would get updated in that case. So this is kind of minor, but still, it's just semantically wrong that we're not keeping that elapsed time in the database as much as possible. And also, it's a chance for me to show you how you would do this, because it's kind of interesting. How do I do something when my database gets saved? So here's how we do that. We're actually going to do this in our little view modifier here. You see we have this wonderful view modifier, elapsed time tracker, and it's doing all this on appear, on disappear, on change of the scene phase, all that stuff. Well, we're going to do it in here. This is, everyone agree, this is the obvious place to do this. This is the thing that's tracking what's going on. And to make this clearer, I'm going to take this out of here. I'm just going to cut it out of my codebreaker view and put it in its own file. So let's go File, New, from Template. It's not a view, it's a view modifier, so I'm going to say Swift file. It's called elapsed time tracker, and of course it's part of our UI. Create it there, and it's UI, so it's import SwiftUI, and paste. There it is. I put the little nicety extension on view that creates this nice little view modifier thing in there too. And so what I want to do here essentially is I want to watch my model context, and whenever it's about to save, I want to update the elapsed time. That's it. That's all I want to do. So if I want to watch my model context, the first thing I need to do is get my model context. So I'm going to do environment, model context, var model context, just like I do anywhere that I want to get a handle on my database. And of course, that's a SwiftData thing. I'm going to put SwiftData up here. So now I have my little model context. Now, how do I find out when that model context is about to save? I'm going to use something that it's hardly worth my spending the time in lecture to show you this, because we almost don't use this anymore because other things have been added to SwiftUI over the years that make this almost obsolete. But this is the way to do it for this specific case. So don't worry too much about this if you're like, what is that notification? What, this, that, and the other thing? But just try to understand what we're doing here in the big picture. This is only 2 lines of code, so don't get too freaked out. But the bottom line is there's a mechanism inside Swift called the Notification Center. And what you do is you go to the Notification Center and you say, give me a thing called a publisher, which publishes every single time something happens. And then you get to specify the something that happens. So here we're going to get a publisher from the Notification Center that publishes whenever the database is about to save. So that's what we're going to do. I'm going to actually create a var that gives me one of those things, a publisher. I'm going to call it my model context will save publisher. And it's of type notification center dot publisher, because the notification center is the thing that does the publishing. So publisher is just inside that struct. So this little publisher thing, you can get one from the notification center by getting a notification center, and we use the default one. And I'm going to ask it to give me a publisher. And this publisher thing has 2 arguments. One is publish when what happens, and the other thing is on what object. So I'm going to say for model context.willSave, that's the thing I'm looking for that happens, and I'll show you where we got that in a second. And the object here is model context. This is our model context. So when our model context says that this is happening, publish that to me. That's all we're doing with this publisher. Now this, I actually showed you this will save the other day. I'm going to show it to you again, so I'm just option clicking on it here. There it is. In fact, let's option click on model context and go look at the whole thing in the documentation. Here's model context. Remember this guy? He's got fetch and insert and has changes. It's got delete, all the things we were doing in that game list. Autosave enabled, save, etc. Well, look down here. registering for notifications. It's got two of them, will save and did save. So will save means notify me just before you save. Did save says notify me just after you saved. This little will save right here is this little will save right here. Now I have a little thing called a publisher that will publish, notify you basically, when this will save happens on this model context. So how do I use this little publisher to do something? And it's really cool. There's a view modifier called onReceive, and you just give it the model save publisher thing, the will save publisher, this thing I built up here. You just give that to it, and every time that thing publishes, it'll call this closure. Now this closure right here will give you the publisher back, which I don't care about. That's why I underbarred it. And inside here, I can do anything I want. This code is going to get executed every time the database is about to save. Perfect, exactly what I want. And what am I going to do here? I'm going to say game update elapsed time, which this is a function that we'll have to write that will update our elapsed time. Pretty easy to write. And I'm also going to print in here updated elapsed time to the game's elapsed time, just so we can see it happening in our console as things go on. So we need to write this code, update elapsed time, on our game. So let's go over to our game, which is right here, code breaker. Here's where we do start timer and pause timer. Let's put it near that. Func update elapsed time. And I thought of a really easy way to elapse the time. Watch this. I'm going to say pause the timer and then start the timer. Right? Because when I pause it, it updates the elapsed time. And then when I restart it, it keeps going. So that will update my elapsed time right there. Simple as could be. Now this one's a little hard to make sure this is working because I don't want to do the scene phase thing to force it to autosave so that it does this. So I'm just going to have to wait. But it might take a little bit of time. So let's go ahead and go here to Mastermind or something like that. Make a couple guesses in here. And then we're going to go back over here. We're going to take a break. And we're going to wait and see if this thing autosaves. And hopefully it'll autosave sooner than later, but if anyone's got any jokes to say or something, we could do that or something. But hopefully this is going to spit out in a moment here something like updated elapsed time to whatever. Usually I find it autosaves in about a minute. It's only going to autosave if there's actually a change in the database, but we did make a change. We did attempt at a couple of guesses. That changed the database. This is live demos. You never know, though. I was going to, oh, I did something. Let's look. Oh, updated elapsed time to 44 seconds. And if we go back here, yeah, it's on 50. Updated it a few seconds ago, so it looks like it's working. So this is a little bit esoteric, maybe, maybe not, but it shows you how easy it is to find out when these things are happening. So let's go back to the slides here. Multi-threading. Don't block my UI. That's what multi-threading is all about here. It is never okay in a mobile app UI to have your UI freeze. Even for half a second, it just, people, your UI, that is the worst thing. Okay, when you have a UI that freezes like that, people are like, where do I delete this app? Okay, it's really frustrating. Cannot do it. Okay, it's just absolute law to not have your app freeze, which means you can't do anything in your code that's going to take a long time. All right, you just can't do it. Now, that's a problem, though, if you want to do something that takes a long time, like you want to go out on the network and get those words for our word game or whatever, or you just want to do something very CPU intensive. Maybe you're doing some machine learning thing or something, and you got to process big matrices of data or something like that. You can't do that in your normal course of your code because it would make your UI freeze. Now, how do we deal with this? How do we stop it from freezing it? We use something called threads of execution. We have multiple threads of execution where actually multiple lines of code are executing exactly the same time. Now, are they executing exactly the same time? It kind of depends on your hardware architecture. If you have hardware that has multiple cores, then yeah, they might actually be executing exactly the same time, or multiple processors. But if you're like on a single processor, single core system that can't do that, then it's time slicing the processor between the code. And so to you, it looks like they're running exactly the same time, but they might be sharing a processor. You don't really care. In your mind, these threads allow multiple things in your app to be running at exactly the same time, running simultaneously. Most modern operating systems have this idea of threads. Threads are complicated and tricky and difficult for programmers to understand because the effects of having 2 or 3 or 10 or 1,000 things all running at the same time are hard for us to get our head around because they might be working on the same data and they're changing it at different times, and some of the threads are running faster than others, and I can't think of it. I just can't keep it in my head. Plus, it's hard for us to think temporally. We can think linearly, but it's hard for us to think, this might be happening at a different time. So how the heck are we going to have these threads and still have our code be understandable and verifiable to make sure that our code's actually going to work and not going to get out there in the real world with customers and because 2 threads ran at different speeds by crashes? In Swift, we let the language or the runtime system manage all the threads for us. So we don't actually ever create a thread, believe it or not, when we're doing multi-threaded programming. We allow Swift to do that for us. But if we're going to allow Swift to create all those threads for us behind the scenes and make all that code run in the right place, we have to help it understand what pieces can be separated, what things can run at the same time, and stuff like that. So that's what Swift is all about here, and its concurrency model is all about helping it understand where to effectively use threads. So let's talk about Swift's concurrency conceptually here. We know the benefit of the concurrency, right, is I can be doing something that takes a long time in one thread while I'm doing the UI, which I need to be responsive, in another thread. That's really a big benefit. But what's the downside of it? Data races is the downside of it. You have shared data between these threads, and they could be stomping on each other. What if you have 2 threads that are both trying to add something to an array, and they try to do it exactly at the same time because both threads are running exactly at the same time? Does one of them win, or the other one wins, or maybe the array gets corrupted because 2 attempts were made to add something to an array exactly at the same time? This is a problem, this kind of data racing between these threads. So how does Swift make sure this never happens, smashed, corrupted data? There are 3 basic ideas to get your head around here, which I'm going to talk about all 3. One is actors and isolation. Actors are the fundamental way that we make sure things don't stomp on each other. Second is waiting and suspending. These are conceptual ideas where you're going to wait for your chance to go access some data, and you're going to suspend when you're waiting. And when you suspend, other things can run. So this is a fundamental idea. And then finally, you have to think a little bit about synchronous operating environments versus asynchronous ones. In synchronous ones, you can't block. You can't wait for a network call. You can't go do something that takes a lot of time. You can't block. But in an asynchronous operating environment, you can. These are the 3 ways that I'm giving you to think about all this stuff, and we're going to dive into each of these and try to understand them. So let's start with actors. Actors are the way we synchronize the data that multiple threads might be trying to smash on. Now, an actor is a reference type. It's extremely like a class. You use it in the same way. You say actor foo, whatever, just like you would say class foo. But it has no inheritance. It's not like a struct. It's not a value type. It's a reference type. But an actor's talent, the thing an actor can do, is that it synchronizes all access to all of its vars and funcs across threads. That's what it does. And I'm going to talk about how it does that in a moment here. Now, if you're not doing any multi-threading in your app, which, like, we don't do any multi-threading in Codebreaker, except for you do in your homework with the words thing, which I'm going to go over that. But in the Codebreaker, there's no multi-threading going on. So I don't have to even think about an actor. We never even said the word actor all quarter long so far. Now, if you're doing some multi-threading, but in concert with your UI, kind of like we do in the words.swift thing there, then there's actually an actor you can use called the MainActor. The MainActor is the actor that the entire UI runs on. And you can use it to synchronize your own code for simple synchronization. I'm going to talk about that. But before I get into the details of how all that happens, let's talk about actually how actors do this synchronization of all the vars and funcs inside of them. First, most important part is that only one func or var on an actor can be executing at a time. No matter how many threads, I got 1,000 threads, they all have to wait their turn to execute any lines of code in a func or a computed var, or even accessing a stored var, can only happen to one of them at a time. Do you see what I'm saying? It serializes it. And you can immediately see how this instantly solves the problem. As long as you put all your data in an actor, no way can two threads both try to add to an array at the same time, because they can only one of them run the code that touches the array. So that's a big part of it. But there's a second part of this, which is that all functions inside of an actor are guaranteed to run to completion or stop at a suspension point. And this suspension point thing is so important, I put it in purple right here. I'm going to have a whole slide to talk about what I mean by suspension. But why is this second thing important, that the code runs to the end of the function or stops at a suspension point? It's because of predictability. When you write your code, you need to know exactly when you're going to swap over to doing something else in your actor. Because you've got to leave all your data structures in a good state before it can switch over and run some other function in your actor. And if you can't 100% know, I mean 100% know when it's going to be switching around, then you can't be 100% sure that you're not smashing on some data structure. The combination of running serially and then having these suspension points really clear and well marked, or if no suspension points, running off the end of the function before anything happens, allows you to write predictable code. So let's talk a little bit about that. When we have a func or a var in an actor, we say that that func or var is isolated to that actor. When you start looking at vignettes to try and figure out how to do multi-threadedness in your final projects or whatever, you're going to see this word isolated all the time. And isolated just means that this func only runs in the isolation chamber of this actor. So anything that's isolated to an actor has to wait for other things to finish before it can run. And when it's done, other things can run. Things get serialized, right? So that's what isolation means. Now, plenty of code in your app is non-isolated. It's not running on an actor. It's just non-concurrency protected, like your model. Your @observable model, it's not on an actor. It's just running out in space. So it can't do any of this concurrency. You can't do multi-threaded with a normal @observable model. You just can't do it because there's no protection. There's no actor that's protecting there. Now I'm going to show you how you could do something in your @observable model if you did need to do some protection. But normally you can't because it's non-isolated. And notice that I put non-isolated there in monospace font because it is a keyword. Because you can put that keyword on funcs and vars and that unisolates them. So if you had an actor that had a func and you didn't want that func to actually play the game of the actor, you can mark it non-isolated and that will make it so it doesn't do that anymore. It doesn't play the actor game. Now your UI always is isolated. Everything that runs in your UI, your var body, every func that your var body calls, all your @state vars, everything in there is isolated to an actor called the MainActor. We're going to talk about the MainActor a lot because it's a very, very important actor. Obviously, your entire UI runs it at all times. But it is important to note that your entire UI is isolated. It is running on an actor. And that means that the UI is not calling two var bodies in two different threads at the same time. It's kind of doing it all synchronously. Although, you know what, there's part of the UI which is happening behind the scenes to you that could possibly be doing some multi-threaded work. We don't know. That's an Apple internal implementation. We don't even care. But our code, we know, is synchronized. So stuff that's running in our code, we know it's not going to stomp on each other. It's not going to be messed up by threads or something. Before I go talk about MainActor and all the UI stuff, let's talk more about this purple thing, suspension, because this is so important to understanding how this makes any sense, this whole actor business here. So like I said, if you're going to be predictable, when you're looking at some code in a func that's in an actor, you need to know that either it runs off the end without stopping, or it runs to a suspension point. If it gets to a suspension point, now other things on your actor can run, and that's important to understand. And it's also important to make it that way because What if you have a func that goes out to do something on the network in your actor? You can't block your entire actor until that thing comes back. So you're going to do a call that's going to allow you to suspend. And your actor will suspend in that function. Other things in your actor will run while you're waiting for that network thing to come back. When it finally comes back, then you'll continue running and you'll run off the end or until your next suspension point. This suspension is really important. And so every single function in an actor that can suspend has to be marked with the keyword async. And you put this right after the func. So you say func foo with its arguments async. And it tells the whole world this thing might suspend. You have to advertise all your functions that might suspend. If you don't mark it, then when that function's called in an actor, it always runs all the way to the end. And it also runs in a synchronous environment, so you can't call anything that might block, which is kind of a good combo there. Now, functions that inside of them do things like network access are always going to be marked async because they just can't block the actor. Okay, so they have to be marked async because they're suspendable, right? Async is really an advertisement that a suspension could happen in there, but it doesn't have to happen. You might have if-thens that never call anything that blocks. You have these functions that are marked as async. They might suspend, and that causes other code to have to pay attention and do something. Namely, when you call a function that's marked async, you have to mark it with await. Just like, when error handling, when we have something that might throw, we have to say try. Same thing here. When we have something that's async, in other words, it might block and get suspended in there, we have to say await. And you can see this await is a great word for that because you are saying, I'm going to wait for that thing to finish. Even though it might block, might take seconds to finish, but I'm going to wait. I'm going to wait it finishing. You also put await in front of calls to other actors. If you're in an actor and you call some function in another actor, you will have to await it. Why? Because that other actor might be busy running other functions in that actor, and you have to wait for them to finish, and then it can run your function call. So you also might say await before calling a func in another actor. So await makes sense, right? We're going to await something that might suspend or block or it's not currently available. So put this all together. Here's the rub, as I say. When a function executes a line of code with await, it might get suspended. So await is the keyword that you can always look for in an actor to see whether it can suspend there. And that means in an actor, every time you call something with await, you better make sure all your data structures are ready for the rest of your actor to do whatever it wants to do, because you're going to get suspended, probably, and other things in your actor can run. So it's your job to coordinate right before you do an await in an actor to make sure everything's ready for all the rest of your actor to run, because you're going to get suspended and it's going to run. And this is what makes it possible to have this actor having this rule where it runs to completion or runs to a suspend and not have it constantly blocked, because it keeps doing things with await that cause it to suspend and let other things run. So that's the key to making all this stuff work. Now, the interesting thing is you can only do an await in an asynchronous context. I mentioned that there's synchronous context. That's the normal coding that you're used to. An asynchronous context. So asynchronous context are the only time you can do a wait. Swift will just not compile if you try to do an await and you're in a synchronous context. So how do you get an asynchronous context? Well, if your function is marked async, you're in an asynchronous context. So any function that's marked async can do as many awaits as it wants inside of it. The other way, or another way, is to put the code that you want to do the await in a task closure. So there's something called a task. I'm going to talk all about it. It takes a closure. It executes that closure in an asynchronous context. So you can do awaits in there. But otherwise, you can't do await. So if you're looking in the documentation and you're trying to, let's say, download an HTTP URL from something, and you look in the documentation, it's going to say, URL session dot get data or whatever, async. You can't call it in your normal code. If you try to just call it, it'll say you have to say await. You put await on there, and it'll say you can't do wait. You're not in an asynchronous context here. So that forces you to either use task or to create a function that has async, but creating a function that's marked async doesn't help much because you can't call that function from a synchronous context. So it's just putting off the inevitable there, and you'll see that in the little demo here. The whole reason that you put await in there, remember, the reason we have it there is the same reason you put try. The reason you put try in is to remind yourself and readers of your code this might throw. The whole reason you put await in there is to remind yourself and readers of your code I might get suspended here, so I need to be ready for that. And you have no idea how long you might be suspended. You might be suspended for 0 seconds, or you might be suspended for minutes if it's some network call that has a long timeout or something like that. When you resume from awaiting this thing to happen that might take a long time, when you come back, other code inside your actor might have run. And it might have changed the world you thought you had. Like if you had an index into an array and then you did await something, and then you come back and then you tried to insert something at that index that you had saved, that might not be right anymore because maybe that array got changed by something else that happened while you were suspended, you see? So you have to be careful going into an await and also coming out of an await because the world might change out of your await. All right, so that's it for async and await. There's this little extra thing to think about with asynchronous programming here with concurrency, which is sendable. Now, actors protect their own data beautifully, right, by having this nice serialized thing. But what if they pass something to another actor as an argument? Now, can both actors start munching on that thing that they just passed and damage that thing? They pass an array, or array that's inside, it would have to be inside a class or something, so it'd be mutable. So they pass something there, and they both start crunching on it, and everything gets messed up. So we have to think about the arguments to functions that we call that cross these actor boundaries, and that's what Sendable is all about. Arguments to functions that are going to go across an actor isolation boundary have to be sendable. They have to implement the protocol Sendable. Now, this Sendable protocol has actually no functions or vars in it. It's just a marker that says this thing can cross that boundary and it won't get crunched. It won't get smashed by two people writing to it at the same time. You actually don't make things sendable, you just mark them sendable. And some things you just can't mark sendable because they can't be marked sendable. So let's talk about those things. Structs can very often be marked sendable. Why? Because structs are passed by value. So if you're passing a struct by value to someone, they can't munch on it and damage it. They got a copy of it, their own copy. They can munch all they want. Now that's only going to work if your struct only contains other value types, other sendable things. Right? If your struct contained a pointer to a class, now it's not sendable because someone could go through that pointer and start smashing things. And this is why structs are great in multi-threaded programming because they're passed around and they're very sendable. They can cross actor boundaries really nicely. Now, actors, by definition, are sendable. Every actor in the world is sendable. Why? Because actors' data can't be munged. Actors protect their data. That's why we have them. So all arguments that cross actor boundaries that are themselves actors, those arguments are actors, always sendable. Including things that are marked with this thing @MainActor, which I'm going to talk about, which kind of puts them on the main actor. And I'll talk about that in a second. Now, most classes, as you might imagine, are not sendable. Because classes are infinitely mutable. You can start crushing them all you want. So it's hard to make a class be sendable. I mean, essentially, the only kind of classes that are sendable are ones that don't have any mutable data, like it's all lets or something like that, or the only mutable data has is sendable data or something like that. Classes are generally not sendable. That's why if we want something like a class that's sendable, we make it an actor. Actors are very similar to classes, don't have inheritance, but they're similar to classes in that they're all mutable, writable state, but they're protected mutable, writable state. Don't forget about closures. Closures are a type. Closures can be marked with @sendable. Again, we're talking about function calls where we're passing arguments between actors here. And if the argument that you're trying to pass is a closure, you can say @sendable on there, which means that when you call that function, the closure that you give in there has to be sendable. So what kind of closures are sendable? Well, most closures are sendable as long as they don't capture something that's unsendable, right? We know how closures capture the variables around them. They can't capture something that's not sendable and then be a sendable closure. So the compiler catches all that, and it won't let you pass a closure that captures something that's not sendable as an argument. But closures are otherwise sendable, and you'll see that there are quite a few pieces of Swift API where you're passing closures around, and they have to be sendable. All right, let's talk about task. I told you that to do an await, you have to be in an asynchronous executing context, and that one way is to have your func be marked async, but the other way is using a task. And if you need to do something with await, this is what a task call looks like. Task, argument is the priority, like is this a high priority task that really should get a lot of CPU, or a low priority task that can just run in the background there. You can go look in the documentation for the various values there. And then you pass a closure, and inside that closure you can do awaits because you are in an asynchronous context. So this is a great way to be able to call something that has await. Now this line of code that I'm showing right there, it returns immediately, instantly, and then executes the closure some other time. Might be almost 0 seconds later, might be 10 seconds later. So you don't know. There's no way for you to know. When you do a task like this, that closure is going to execute sometime in the future. Now that green task thing that comes back, it's a nice little object, lets you cancel the task if you want to give up on it. The task actually can return a value, so you can get the value that's returned out of there. But a lot of times with the task, we just let it run. We just give it that closure, and the closure just runs, and we're not canceling it or doing any of that stuff. One thing about a task that's important to understand is that it inherits the actor isolation that the let task equals line of code had. Right? So if you do let task equals this task in some code that is isolated to the main actor, then that closure is going to run isolated to the main actor. Now I'm going to show you a trick where you can actually make the closure run in a certain actor, but if you don't do this trick that I'm going to show you, and it's like this, it inherits the isolation. I talked about these passing of closures between actors, so I wanted to show you a couple of view modifiers that take async closures as arguments. And when you have an async closure, this means that the closure automatically gets put into an async operating environment. One of them is .task. This is an awesome one. You put it in the same kind of places you put on appears. So you say .task and you give it a closure, and then that closure is going to be executed when the view comes on screen. That task will start running, and if view comes off screen, like it on disappears, then the task will be canceled. So it's a task that runs only for the lifetime of while the view is on screen. So it's awesome for loading up some data to get the view started or whatever that is slow to load, like it's coming from the network or something or needs some processing. It's awesome for that. And this is also going to inherit the same actor isolation, which is always going to be the main actor here, because the .task is a view modifier. It's going to be attached to a view. That's going to be in the body or something like that. It's going to be main actor. Now another cool one is .refreshable. You guys know how you have a list inside of like a navigation view and you can pull down on it? You've seen this in other apps. And a little spinning wheel comes at the top. That you get by just saying .refreshable and giving a closure. And when you pull down, it'll automatically put the spinning wheel and it'll start executing this closure in the background. And as soon as this task finishes, the spinning wheel will stop and it'll slide back up. Or if the user pushes it back up, it'll cancel this thing. Yeah, so the question is, these are marked async, so do these inherit the actor isolation? Absolutely they do. So they inherit the actor isolation of whatever you're attaching them to. But again, they're view modifiers, so you're attaching to a view, so they're going to be main actor. Yeah. Let's talk about the main actor. This main actor is just an actor. It's called a global actor. And a global actor is a little kind of a special actor because you can put other code in other structs and classes onto this main actor. Right? So this is kind of weird. And everything in the UI runs on the main actor. This is really because the view protocol, that behaves like a view, that view protocol, it's marked with this global actor thing. So everything that happens with that protocol is on the main actor, which means everything in a view essentially is in the main actor. So all activity for the UI has to happen on the main actor. This happens naturally in SwiftUI, so you don't really need to think about this, but it is what it is. All of your vars, everything in your view, would automatically run on the main actor, which means they're all completely thread safe, which is awesome. Your model, however, is not on the main actor. So code that's going on in your model is not thread safe. So if you're going to do something there that's multi-threaded, you will have to do some of this actor business. Now, the @sign observable mechanism, you know, this @sign observable thing that lets you update a var and then it automatically updates the view and all that stuff, all that machinery, that's all main actor isolated. So you don't really have to worry too much about setting your vars in your @sign observable. It's going to eventually end up on the main actor when the view gets rebuilt. So don't worry too much about that. That means that you really only have to think about actors or actor isolation in your model if you're doing multi-threaded things. Like if your model is getting something from the network. Now you need to start thinking, how am I going to do that? I need to have a task or something that goes off and in an asynchronous context does an await. Now, normally, a great way to do this is just to put your @sign observable thing onto the main actor. And incredibly, you can do this. And there is a little macro called @sign MainActor. You can put it on a var, you can put it on a func, you can put it on an entire class, and it will make everything, that func or var, or the entire class, all its functions and vars, run on that main actor. So it's kind of weird to think about this because we know that actors are like classes, and we're thinking of all the vars and funcs on that thing being all synchronized. But this @sign MainActor thing basically makes it so that all these vars and funcs on these other things that are marked with this also have to run in that same actor isolation. They're isolated to the same actor, which is awesome. Now, of course, anything that is isolated to the main actor is going to run in the same serial thing as everything in the UI, so you wouldn't want anything that took a long time to ever be on the main actor, right? Some big data crunching, no, you would never put that on the main actor. You would want that off on some other thing. But it is a cheap and easy way to have actor isolation if you want to do a little bit of multi-threading in your model. And that's exactly what we do with the words.swift. And I'm going to show you that in the demo here in a second. We're going to use @sign MainActor to bias safe concurrency when we do this little thing where we fetch this small file off the internet. Now, if you're doing heavy-duty multi-threading, like let's say your final project is your research project in quantum mechanics and you're doing these massive matrix multiplications and stuff like that, you're going to have to create your own actor for that. And by the way, it can't be an @sign observable actor. There's no such thing. It's not allowed. Compiler will not let you say @sign observable actor, which makes sense because, think about it, that @sign observable thing is needing to talk to the main actor to update it and all that stuff, so it doesn't want to have actor boundary to have to cross over there. But it doesn't mean you can't have your own actor that you just invent, actor research project, and inside it is all this data that's got multiple threads pounding on some data structure that you're manipulating. That's all perfectly fine, and your @sign observable class could fire up a task and get that thing going, get it running. So that's perfectly allowed. Do I think any of you are going to do that in your final project? No, I do not. I think most of you can use @sign MainActor if you need a little bit of synchronization going, but I just have to say that it's possible to make your own actors. A couple of tricks I told you about, I was going to tell you about this. If you want a task to fire up something in a context where you're non-isolated especially, or if you're on another actor, but if you're non-isolated, you can force the closure to run on the main actor, to be main actor isolated, by just saying @sign MainActor in at the beginning of the closure that you pass to the task. So that's pretty cool because all the code in there is going to run on the main actor. And there's another little one you can do, which is MainActor.run. You give it a closure, it'll run that code on the main actor. These two seem almost identical. They're slightly different in whether they run the code immediately or not, but don't worry about it too much. I recommend doing the one at the top, the task @MainActor in. It's just a really nice way to get an asynchronous operating context where you can do awaits and still have your code all be running on the main actor and be synchronized. So let's go back and look at words.swift because it does some of this stuff and see how it does what it does. Now, I don't even use words.swift in CodeBreaker. Of course, you do in your assignment, but here it is. We can get rid of this because we're not doing any UI stuff here. But here's the main thing to look at in words.swift. You see that there? that await. That marks the point where we're doing asynchronous programming, where we're doing concurrency. And this is kind of an interesting little await right here. This is a wait embedded in a for loop. So I'm sure when I was saying, oh, you have to mark a function call with await, you're thinking await, call function, whatever. And yes, we do that. But for await, word in is kind of cool. So what's happening here is this little var right here, lines, which is on URL. This is URL as a struct, so this is just a URL. So if you ask a URL for its lines, meaning the new line separated lines in the file, it will give them back to you with something called an async sequence. And this async sequence allows you to break up some thing over the network or something that's going to take a long time into little calls. And so every time I go around this for loop, it might go back out to the network to get more. Now, with our common words, it was only a couple thousand lines. It might load it all in one go. And every time I call lines, it just gets to the next line that it's already buffered. But what if it was hundreds of thousands of words? Then maybe it would get the first 5,000 and then go for a while and then have to wait again. So every time this await happens, like I said, you could suspend here, but you might not. Await just means you might suspend here. Since this suspends, it has to be in an async environment. So what makes this await in an async environment? Can anyone see why this is allowed to do await here? What makes this code here asynchronous? Yeah, it's this task right here. The task, by definition, forks off an asynchronous operating environment for us to run in. So that closure is running asynchronous. So I can do all the awaits I want in there. Now that's different from the isolation. This is non-isolated. It's running non-isolated, but it's still asynchronous, and so it can still do awaits in there. Now, we're going to find that its non-isolation is a bit of a problem, but it's currently non-isolated. Now, I'm going to show you something to help you understand this async thing. I'm going to take all of this right here out of here, and I'm going to put it in its own function. Private func load from URL, returns, one of these things, paste, return the words. And I'm going to call that function, load from URL. A couple of things here. Look what this is saying. Async in a function that does not support concurrency. In other words, I'm doing an await in a non-asynchronous environment, synchronous code. Because I took this code out of the task. Right? This task up here makes things asynchronous, but I took it out. But I can put it back in by saying that this is an async function. You see, by saying this is async, it tells the system, oh, I might suspend in here. So anybody who's calling me better be ready for that. And that just pushed the error up to above. Look at the one up here. Now it says this expression is async, but is not marked with await. Now that load is an async function, I can only call it by saying await. Without await, it makes no sense to call an async function. You have to wait for it to finish. See what's going on there? So this is a normal looking await for a function to finish. And it's just calling an async function here. Everybody understand that? Now I'm going to show you another kind of cool thing here, which is really weird. So you would never do what I'm doing, but I just want to show how it works because I need something that's actor isolated. But what if I said let mm equal match markers, matches, no matches. So I just set mm equal to an instance of a match markers view, which is totally ridiculous to do here. But I want to do it because match marker is a view, so it's actor isolated to the main actor. And I'm otherwise in non-isolated code here. So watch what happens if I say let body equal mm's body. So I'm just calling the body var on there. I get an error here. This expression is async, but it's not marked with await. Why is that expression async? Because I'm in a non-isolated environment. I'm trying to access something in an actor. I need to wait for that actor to come free, because that actor only executes all its vars in series, in sequence. So I have to actually say, if I wanted to do this, await. And when that actor is finally done doing whatever other things it wants to do, then I can finally call this computed var and get my thing. You see why I have to do await there? this var right here, that computed var, is actor isolated because all the vars and funcs on the match markers is main actor isolated. So the question is, why is that true? That body and all of the other vars are actor isolated to main actor? Is because, yes, the view protocol is main actor isolated. So anything that implements the view protocol and everything in it is going to be main actor isolated, including var body. All right, but of course we would never do this. That makes absolutely no sense. But it's the only actor isolated thing I could get my hands on there to show you how that works. Now, this has no errors, but is this really thread safe, this code? And the answer is no. This is very much not thread safe code. Now, it's going to work just because of the way I use it, but not because of the way it's written. So why is this not thread safe? Well, I've got vars like words, and especially this shared thing right here, that multiple people can access, and they could be smashing on it, destroying this dictionary. This dictionary could absolutely be wiped out. If I had functions down here that were adding things to the words, deleting things from the words, and I had multiple threads doing that, they would all just be crushing on this thing and just destroying it. Now, none of that happens because I only ever touch my words in init when I initialize it. I don't actually do anything but read the words down here, so everything is probably okay. Although, you know, if I read the words down here just as I was putting them in there, if I was doing that in another thread, maybe that would be a problem. So this code is not thread safe. It has too much stuff that's just not protected. There's no actor protecting anything. It's non-isolated. Now, why isn't this complaining? Why is the code here not saying, oh, all kinds of concurrency errors here? Well, that's because I'm not running this with strict concurrency checking. In Swift 6, which is the compiler that you're using here, they created a new language mode, the Swift 6 language mode, that does strict concurrency checking. But not everything in the world, especially not everything in SwiftUI, has yet been updated to it, so it's not enabled. But I'm going to show you how to enable it so you can see what happens. So I'm going to go over to my project here. I'm going to pick my target, my codebreaker target, and here I've searched already for concurrency. And you can see strict concurrency checking. It's currently on minimal checking. I'm going to change it to complete checking. So this is actually going to be able to incredibly analyze my code statically and figure out, whoa, you got a possible data race there. You need to protect this. So let's go back and look at what kind of errors it's saying here. It says this static property shared is not concurrency safe. Because words, this thing right here, which is a part of it, is not sendable, which is clearly not. We have this in a class right here. This is all mutatable stuff here. So how could I fix this to make it so that it's concurrency safe? Well, I need to actor isolate it. It needs to be isolated in actor. How about this? @MainActor. I've just made it so that this var can only be read or written by code that is on the main actor. So like code in my UI could do it, things like that. Since it can only ever happen on that main actor and only one thing can be executing on that main actor at a time, this has now become thread safe. There's just no way for two threads to modify it at the same time because only one of the threads can actually be running on the main actor at a time. Now, what about this one? Passing a closure risks data races here. Well, maybe this closure, what if I made it @MainActor? That would cause everything it's doing in here to happen on the main actor. That would make sure that it's not conflicting with anything else running on the main actor, but it really doesn't solve the problem. And you can see this by the error. Sending self risks data races, because this is really self.words, self.count. So I'm sending self onto the main actor here, nicely, but I got plenty of other code down here that is all non-isolated that can access words and count. So that is not protecting it. To really protect it, all accesses have to be on the same actor. So how can I put all accesses to word onto the main actor? Well, I'm just going to make my entire words be isolated to the main actor. And this is a nice, simple trick that you can do. It means you don't have to do this. Okay? You definitely don't have to do this because @MainActor on the whole class means all of these vars and funcs run MainActor isolated. Now, it does mean if anyone wanted to access these words not from my UI, not from my MainActor, they'd have to await this thing. They'd have to do it asynchronously and await on it. But it's fine because I only ever intended you to ever use these words on the UI. That's kind of why I did this thing with @ environment for the words. I wanted you to use it in the UI. Some of you went straight to shared here and started using it in your model. I never intended you to do that. I probably should have made this private. That would probably have been a good thing so that you wouldn't even use this shared thing. But this is fine if I make this a MainActor. It means I can only use words on the MainActor without awaiting, and that's perfectly fine. That's what I intend. Now, what about this last error here? MainActor isolated default value is in a non-isolated context. Well, that's because environment values, that thing, is non-isolated. And specifically, there is a protocol kind of built inside of this @ entry called environment key. And it's a protocol that does not allow actor isolation. And so when this thing tries to use an isolated default value for something, it's like, no, I can't do that. And if I had more time, I would show you how to get around this. The way to fix this is to not use @ entry here and to work around the lack of isolation. But you can kind of see that this is part of the reason that this whole concurrency stuff is not enabled yet. Right? Because this is a normal thing to want to do, to have an @ environment whose default value is something that's isolated to the MainActor. And you can only use @ environment in the MainActor, so why wouldn't I be able to do that? So I should be able to. And they just haven't gotten around to making this work. But eventually, they'll fix it all. And they fixed a lot of things, because not much stuff is complaining here, but there's still more to go there. Maybe I'll post on Ed how we would do this in the old way so you could see how to make it work, because it can be made to work. There are some other errors that came up through this thing. Like, I think there's an error in here. Actually, I think it's in, I think it might be in our extensions. This peg chooser right here, look at this. This is complaining that peg chooser is not concurrency safe because any transition, this is a little static any transition thing we created, the transition we use for our peg chooser going down off the bottom of the screen. It's saying any transition is not sendable. And if you look over here in my code breaker view, look what I do. I do transition peg chooser. I'm passing that out, and it's not sendable. So that's a problem. So this would have to be isolated to the MainActor as well, or it'd have to be sendable. Now, why they haven't made any transition be sendable yet, I don't know. Okay, maybe it's got some var in there that's a class that they can't do it. But it's an easy fix here. We can just make this thing be @MainActor as well. That puts it on the MainActor, and now it's not going to be sent across any actor boundary, so it's fine. It doesn't have to be sendable in that case. And there's some other things. If you go get this, I'm going to post this code, of course, and if you compile it, you're going to see some other things, like over in our predicates. Maybe we could see it here. Let's build. And go to see our errors here. These key paths inside of our predicate, those key paths aren't sendable. Again, that's stuff that I'm sure they're just going to fix once they get this whole thing fired up. And then when they do, then they'll maybe make the Swift 6 language mode be the default, which will be great. But if you're doing your own multi-threaded programming, you would definitely want to turn on that strict concurrency checking and get your code at least all compiling with that, because then you can be sure that you're not stomping on your own data structures there. Hopefully you're all turning in your assignment 5 today. Is today the due day? I think it is, hopefully. And also hopefully you're all starting your final projects today, or close to today. You get this from all your teachers and all your classes, I'm sure, but when you have a 3-week project, don't procrastinate, okay? Get started, at least get it thinking in your mind, get some code down in Xcode, just get started, because programming is like doing crossword puzzles, right? You you're doing it, you can't get 26 across, you're like, there's just no way, can't get 26 across, I just don't know what it is. You go to sleep, you wake up the next day, you're like, oh, I know, 29 down is this, now I got 26 across. Same thing with coding. You're like, I just can't get this to work, it will not work. And then you go to sleep, and the next day you're like, oh, what if I do this? It happens all the time. So give your mind, your subconscious, chance to work on your final project by starting it early and working on it a little bit day by day as the days go by. It will be a huge benefit. If you try to cram it all in that last week, it just will not work. There's just too much new stuff for you to learn, etc. And if you have any questions about your final project, Ed discussion, I'm always quick to answer. I'm happy to answer any questions about how to make things work, etc. A lot of your final project, you're going to be using AI. That's fine. Just make sure you credit AI when you're doing it, or Google searching, vignette learning. Now's the time to start doing a lot of vignette learning how to download something from the internet, go look it up, and you'll have to do it in a wait, but you'll figure out how to do it, okay? That's what the final project is all about. Also, final project, please go do stuff I didn't do. Maps, Swift charts, things like that. Stuff I didn't even talk about. Go figure it out. Go do those things. That's how you learn, all right?